Okay, so I think it's time, right? Yeah. So let us start. Today we will not do much, to be very honest. What I will do today, the plan is that, first of all, by the way, welcome to the course. Uh, so the idea for today is to just talk about the modalities, the administrative part, grading part, uh, assignment part, what to expect of the assignment, homework, practical, and so on and so forth. Talk about the syllabus, what is the syllabus for this course, how much we can cover, what we will not cover, and then maybe to introduce very briefly about AI and machine learning and deep learning. I mean, how are these three terms different? AI versus ML versus DL is how I like to call it, and so on and so forth, right? So that is kind of the plan for today. Um, For today, I will be using slides, to be very honest, because there is nothing to write today. But in general, the course will be about, so I'll be doing the derivations and writing stuff, and that's how we'll proceed. So it will not be a slide-based course. So there will be a lot of derivations. So if you don't like derivation, probably this is not the course for you. So the mathematical aspects you should be interested in, because there will be a lot of derivations. Okay. Now the course is called Deep Learning for Mechanics. All of you know because you have registered. Now this time there are two codes that are there, APL 745, I think the undergrads have registered for that because that's a 3-digit one. And then AML 780, that's for the masters and PhD one. I mean, obviously slowly only the 4-digit one will remain because the 3 digits will cease to exist, but this time at least it is both, okay. Now the course is called Deep Learning for Mechanics, but the course is primarily about deep learning. We will talk about application of deep learning in mechanics in today's lecture. And then the only mechanics that will come in this course is in the data sets that are provided to you in the practicals and homework. And even that might not come from the first or second practical, that might come from the third and fourth practical. So the course is fundamentally about deep learning and the mathematics of deep learning and the intuition of deep learning and implementation of deep learning. And then the implementation, where do you implement it? That will be some mechanics data set that we will generate and give it to you. Obviously, when you are doing that homework, you have to explain what it means, if the explanation or the prediction is even feasible or not. That is some mechanics that is there. But so if you do not have a mechanics background, that is actually okay. I mean, whatever mechanics is needed, you can, I mean, that is not that significant, okay? Because, and I'm mentioning that because I know there are students from School of AI who are registered here. They might not have a mechanics background. And so for them, basically, this is the disclaimer, okay? So the course is fundamentally about deep learning. Everything about the course, there is the course website. I mean, yesterday I created it in the evening. So that is your one-stop solution for pretty much everything. The lecture notes will be available here. The lecture are being recorded, so that will be uploaded on YouTube and that will also be available here. Homeworks will be provided here. Practicals will be provided here. TAs, if you need to talk with the TAs, their names are provided here, and so on and so forth. So one-stop solution. Except one thing, everything is here, and that one thing that is not here is, or that will not be through this, is submission. I mean, submission cannot be through this website. Submission will be on Moodle. I mean, but everything else will be here. I guess all of you have already my email ID. So any doubt, you just feel free to write to me, meet me after the class, come to my office anytime you want. If I'm there, I'll be happy to talk. Or email me, whatever. All of that is fine. But the only request is that when you are writing an email to me, just write APL 745 or AML 7800 in the subject of your email. So for example, if the email is about a query, just write square bracket APL 745 or AML 7800, whatever the course you are, close the square bracket and then write the subject. How will it help? It will help because I get a lot of emails and it is very easy for me to lose track of emails. So with this, and I will not remember what your subject was if I have not replied to you, let's say in 2 days. But with this, I know what to search and I will get all the emails. And if I miss something, I might reply in 2 days. Without this also I will reply, but I might, if I miss, I miss. I mean, in that case, I will not be able to track that. So it is for to make my life easier so that I can track it. That's all, right? As I said, everything has to be submitted on Moodle, so that we will, I mean, so Moodle links will be created. We will use the old Moodle, not the new one. The new one we will not use because in my experience last semester, the upload limit, the file size is 5 MB, whereas in old it is 25 MB. So because of that, okay, because of the upload limit. Slot, right? So slot 2 you already know, that is B slot. This is the timing, Monday and Thursday. What we need to decide is the practical, right? And for B there are some dedicated practical slots already, but which is, there are 4 slots, you have to select one. But let us decide that now, okay? I know there are some who might not be attending today, but I announced it and we have to decide it, so that's how we'll do, right? So anyways, it's the first day of lecture, so hopefully I'm announcing before anyone, right? Uh, so the options are, let me see, Tuesday and Friday will not work because I will myself be attending a course, something, right? Uh, Wednesday will also not work, so it is basically Monday and Thursday, one of these 2 days. And then I'm kind of flexible with time in the second half, obviously. It can be 2 to 3, 2 to 4, 3 to 5, 2:30 to 4:30, whatever works. So I am going to go ahead and suggest 3 to 5. All the, if there is there any objection or do you have any lecture at that time? I think I might have something on Thursday. No, I'm suggesting Monday. Okay, Monday. Yeah. Okay. The only problem that might have if someone is registered in AA slot or AB slot. I think those are the ones that might have problem. I mean, for those who are practical, I'm guessing no one has announced yet, so I'm announcing first, so I'm fine on that one. Okay, so please check that you are not in A or AB, because Monday and Thursday, both days, I mean, A and AB will have problems. So I'm going to suggest 3 to 5. It might be 3 to 4:30. I mean, we might not need 2 hours, but in that. So we have a course instead of Monday and Thursday, 3:30 to 5. Okay, so then let me suggest 2 to 4, you can leave at 3:15. Okay, 3:15, 3:20. 2 to 4. So you are in AB slot, right? Okay. 2 to 4 Monday. Okay. So we are going to finalize this then. Okay. 2 to 4 on Monday. Okay. I mean, it can also be 1:30, but that is, I don't want to take during your lunch times. So although officially I can, but I don't care. Okay. So 2 to 4, right? So please note it down. Note it down. I'm not writing it down. Okay. So I will update it on the website. So 2 to 4 Monday will be the practical. I will communicate over email whether this Monday there will be practical or not. Most probably there will be no practical. What do I do? I mean, there is no event, not lecture yet, right? So this Monday there might not be practical, but 2 to 4 will be the practical time. And I'll talk about what will be the practical details and all of those things. So, okay. So lecture Monday, Thursday, practical Monday, lecture in B slot, practical 2 to 4 Monday. Okay. Great. Now the main important part probably for all of you, let us see. There are multiple components in for grading, right? And each of these has a slide of its own, but let me give a broad overview and then I will go into details. So there will be homework, there will be practical, there will be a term project, there will be minor and major. And probably minor and major are the least important parts in this 5 components. And that is evident from the weightage that I have shown. Now, minor and major combined has 25% weightage, 15 and 10, major 15 and minor 10. And homework has 25% weightage. There will be 3 homeworks that will be given to you. I will only take 2 out of 3. Okay, so one is I mean, if one you did not do well, you are fine. Okay. Uh, Practical, every 2-3 weeks you expect a practical, so I'm expecting 5 to 6 practicals, um, and combining those practicals we'll have 25% weightage. Term project, so that is basically a project you have to do as part of this course, because this is a, to be very honest, deep learning, learning the maths is important, that will happen in the lecture, but learning to implement is also important, that will happen through these parts. So term project, you have to do a project, I'll give you more details about that, and it will be a team effort, the term project one, and it has also 25% weightage. Okay, and then minor and major has 10 and 15% weightage. Attendance policy, the institute one, I don't want to put anything else. The institute one is that less than 75%, one grade goes down, I think nothing more. Audit criteria. Audit criteria is that passing grade is 40% in absolute scale. Okay. And along with that, there is one more criteria that you have to submit at least, okay, I'll make it 1, so at least 1 homework, I'll change it, not 2, okay, at least 1 homework and 50% of the practical. So if there is 5, then 3, 6, 3, 4, 2, something like that. So you should submit 50% of the practicals, submit at least 1 homework and complete the project. Now you can imagine this is a very reasonable criteria because the 75% weightage is on those. So to get 40%, that is where you have to anyway score. So you will not pass the audit criteria without doing this. So, okay. So 1 homework, 50% of the practicals, and complete the project. Okay. So that is the audit criteria for this course. Okay. Anyways, this will be uploaded on the website, so you will get all of this. So I'll obviously I'll correct this. Okay. Rakesh, remind me, 2 to 1, that correction has to be done. Okay. Okay, so now some details, what to expect in the homework, because it seems quite loaded, and to be very honest, it is loaded. Okay. So homework will have 2 types of questions primarily, and they might be linked, they might not be linked. So there will be theoretical questions, mathematical questions where you have to derive things, derive stuff, sometimes prove convergence or something like that, sometimes just derive some loss function or something like that, right? And that part you have to do, you have to write by hand. Typed homework will not be accepted for the theoretical part. It has to be written by hand. Yeah, writing on tablet and submitting, that's fine, but it should be your handwriting. That's what I want. Okay, don't type in LaTeX or Word. That's what I meant. Now there will be also programming components in the homework. Programming components will be given to you on Kaggle, and it will be a competition. So if there is a programming component, whoever gets the best result will get the highest marks, assuming you have followed the correct procedure, obviously, and whoever gets the minimum marks will get the minimum marks, right? I mean, yeah, minimum accuracy will get the minimum marks. So it will be a competition. Whatever programming component is there that you have to submit on Kaggle, also on Moodle you do submit. I mean, just for completeness, but that will be yeah, that will be a competition. Okay, and along with that, for each homework, after the homework submission deadline, we will have a viva where we will ask question about mostly about the theoretical and the practical questions, how to test your understanding. And this is true for homework and practical both. Your marks in the homework and practical, which will come later, will be calculated as marks you get in viva multiplied by marks you get in through your submission, which means even if you got the highest marks, you get 0 in viva, it becomes 0, because it is to get the best marks while understanding. Okay, and you can probably understand I am doing all of this because of the LLMs. Okay, I am not stopping you from using LLMs, but probably only LLM will not help you. I mean, that's the point. I mean, that's why it's a competition. Blindly using LLM will not help. I mean, if you understand and then use LLM to actually improve, then it's probably going to help. So LLM should be a tool that you are using. It should not be that you are blindly using LLM, and if you use, that will result in your marks. So that's the whole idea. There will be 3 homeworks, I said. Best 2 out of 3 will be considered. The deadlines are here. Obviously, I have written the wrong dates, you can see. So look at the right ones. Okay. The submission one, and the submission one is actually the release date. Ignore this portion. Only look at this portion. So it is like announcement, and announcement is this one. I'll correct it. Okay. So I was basically took the last time I taught deep learning and editing it. So last time I taught it on winter, so that's what you were saying. Okay. So announcement is last week of August, second one is third week of September, and the last one is second week of October. Each one will have what? Depending on the length, 2 to 3 weeks, mostly 2 weeks time you will have, right? Any question until now? Practical. Practical will only have programming components. Again, competition, whatever I said earlier is valid for here, and here I have categorically mentioned leaderboard marks multiplied by the Viva marks. Okay, so this is valid for the programming component of homework as well. Important dates I have not given anything, but expect one practical every 2 to 3 weeks, depending on how much is covered in the class. Okay, so in that sense. Term project. Okay, so term project, there are few steps. Let me see. I've reduced the number of report this time. So, but let's see. So you have to select a deep learning based research paper. Obvious deep learning course, deep learning based research paper. The list of papers will be circulated by us. So we will be giving you a list of papers. You select it. It will be first come first serve. Okay. And I will see how to do that so that once someone has selected the option, the option should not be visible to others. I think Microsoft Office allows it. So Office Microsoft Form is what I will use. Okay. And now in the project there are 2 parts, and you will be marked in both the parts. And accordingly there are only 2 reports this time. The step 1 is reproduce the results of the paper that is given to you. Just reproducing the results. Okay. And obviously after this there will be a viva to test your understanding, whether you understood the paper and whether you reproduce it correctly or not, or whether you reproduce it after understanding it or not. Okay. And step 2 is once you have reproduced it, hopefully by September end, you now improve upon that. And that improvement can be a delta X. You come up with your own strategy to improve that, and based on that. Reproducing the paper, I have not mentioned it here, but I am telling you now, reproducing the paper will have 60% weightage. Improving it will have 40% weightage. Because it's a course after all, so I'm not expecting you to be a researcher, to be very honest. But I want you to give it a try, and I want to test your independent thinking on topics that are not available anywhere. So that's why that's 40%. Okay. And there will be viva, or there will be. So you have to prepare reports, make PowerPoint presentation. PowerPoint presentation you have to make only once. So there will be one viva after the first report and presentation at the end of the course. Report twice, step 1 and step 2. You can work as a team. I mean, you don't need to work alone. You can have, each team can have maximum 3 members. So either 1 member, 2 member, or 3 member. You decide, you form your team. I will not do it. Okay. In the report, you categorically mention which team member contributed in which part. Because working in a team does not mean the team members will get equal marks. Because there will be a viva, so in that case, and that viva will not be happening as a team. That viva will happen separately. So naturally, the marks can still be different. So yeah, you should understand the whole thing and your portion particularly. And in the report, you should categorically mention that who has worked on which part. Some important dates, list of papers will be given to you by August 10. There is one caveat, not caveat, but one, what should I say? So one additional, not constraint, but option I am giving you, that if you have already some paper in mind in deep learning, you can let us know by 5th of August. And then we will check it, and if we found it relevant, we will also put it in the list and assign you that one. So in that case, it will be automatically assigned. If you can come up with a paper, and we found that paper to be relevant to this course, that paper will be assigned to you before anything starts. Okay. I mean, this is, I mean, those who are BTech students, it is, and MTech also. This is like your BTech supervisor, MTech supervisor. Go and discuss and find, or otherwise CGPA based. So it will not be CGPA, but first come, first served based. So that is the change. Okay. Report, I already told you the dates are here. So September 30th, September end is the first report. The other report will be on when? November 14th. Presentation might happen at the end of the semester, I mean after your exams and before the grading, there is some 3-4 days gap at that time. Or if time permits, we can take it earlier also. So we'll decide it later. Final presentation will be decided later. Okay, so this is the, I think, one of the parts that we are interested in. So I'll stop here and maybe take questions if there is any doubts on these parts. Let us clarify that before I go to the books and all of those things. So any question on homework, practical and term project, or in general in grading, even minor and major? Okay, so difference can be that not everything can be given in the, so this course is loaded, right? So not everything I will be probably able to give only in the practical. So I'll give you an example. Let's say I covered CNN as an example. Now CNN might have different architecture. One of the architecture I might ask in the practical, the other might be in the homework. And homework, if for some homework I'm giving more time, in that case that program might, I mean the lengthier one will go to homework. So otherwise there is no different as such. So it's just to balance and cover everything on the practical side of everything, right? Anything else? Any question on the minor? I'll tell you. So out of minor and major, one will be on Moodle MCQ. Probably the minor, 10% weightage what to take, quite take a 2-hour exam. And one I will take a proper exam, which is probably the major. Although 15% weightage, but still, I mean, yeah, at least one I should take. Otherwise, they will catch me and say that you are not taking proper exam. Okay, I mean, to be very honest, I believe that minor and major can also be eliminated because this course is about practically implementing things, and that is already being tested in the first 3 parts. I'm keeping minor and major because, okay, that's fine, very minimal, and then that also gives you a chance to at least 25% chance that gives you. Okay, so that's okay. Yeah. No, very good question. No, you can, so in the lab session, we will generally discuss the practicals, what is expected of the practical, and some doubts you have, we will clarify there. The practical sets are to be done in your hostel, home, wherever, right? And you can also sit in and do it. Okay, and that is one of the reasons that we are bringing the Viva component. So mostly the practical sessions will be about your doubts and taking Viva. Okay, even the homework Viva will take in practical session only, so it will be mostly about that. Okay, and that will obviously Viva you can understand. Once you have submitted, then immediately next practical will be the Viva. I mean, understandable, right? Okay, any other question? Location, right? Oh, I don't know. I have to book some room. When I get it, you will get an email. So practical, I mean, we have to book ourselves. So we'll book. I will see what rooms I get. By the way, practicals will not be recorded. Only the lectures are being recorded. Uh, and so that might not, I might not need a room like this where there is camera and all of those things. Although now even I mean, those LTs also have cameras. So, but anyways, most probably I'll try to keep it on in LTs, LT4 or I mean, yeah, something like that, LT42 or something like that. Okay. Okay. Any other question? No. Okay. One thing I did not announce, that is about attendance. I already announced, but as a policy, this course is of 1 hour and 20 minutes, right? So please do not enter if you are late by 7, 8, 10 minutes. Okay, let's put it 10 minutes. So if it is 9:40, please don't enter because you are disturbing the class, disturbing me. Anyways, I am recording and giving it online. See that? Okay, I mean that's okay. So please do not enter if it is 9:40. I will not allow you to enter. I mean, let's put it that way, right? So please do not enter if it is 9:40. Okay. Okay. Books, right? Hopefully, you will not need books. You will need books, but hopefully, I'll try to give enough notes that should suffice. So, in fact, what I will give, I'll tell you now. There will be a slide deck like the one you are seeing here that will be uploaded for each lecture. But and then while teaching, I will be using let's say some tablet, and that will be projecting and I will be writing and doing derivation, that will also be uploaded. And plus the video will be uploaded. So hopefully that will be enough. If that is not enough, these are the books that I am referring to, or I usually refer to any of this book. I am a big fan of the Murphy and Bishop. Bishop is not written here. So they have machine learning book, they have deep learning books. I am a big fan of them. Goodfellow is, if you are new to this course, Goodfellow is a good course to follow, a good book to follow. And anyways, there are n number of lectures on deep learning recorded by MIT, Stanford, Coursera, and all of those. You get free to refer any of those. Okay. CMU also, I think we should have some. Okay. So there is, I mean, machine learning, deep learning, there is enough material online. So that should be enough. Okay. And then sometimes with the lecture, I might provide some, I mean, at least with the slides that I will not show in the lecture, but I will upload. There might be additional reference, so do look into those. Okay. And remember that this is a 700, 7,000 level course, which necessitates to have 20% self-study component. Treat the slides and slide plus delta x as your self-study component. I mean, the slides might have little bit more information than what I am covering in the lecture. So that is your self-study component, nothing more than that. Okay. Topics. So there is a change from last time. Last time I taught it. I mean, those who have seen my website might have seen the courses. So there is, I'm not, I mean, and in the courses they might have seen the topics that were covered. So what has happened, I'll tell you. So while updating the syllabus for the 7,000 level course, there is a new course that has been designed, which is obviously not for the UGs, but it has been designed, which is known as scientific machine learning. So some of the portions that we used to cover here, like physics informed neural network, neural operator, that has been moved to that course. So as a result, there will be no physics informed neural network, there will be no neural operator and stuff like that. As I said, this will be more about the deep learning stuff, right? Not the scientific machine learning stuff. So it will have, so instead of those, you will have something like graph machine learning, you will have deep reinforcement learning. I'll try to cover a little bit of meta learning also, if time permits. And obviously there will be generative model again, I will not cover, that is a separate course, but I will cover generative language model. So I'll cover a little bit of generative model, which is autoregressive generative model, and then combine it with transformer and discuss about generative language model, how GPT is, basically GPT is what I will talk about. Okay. And before that, obviously attention, transformer, RNN, LSTM, these are for time series data or sequence, not time series. And then for images, you have CNNs and family of CNNs. For usual, there is the feed-forward neural network, fully connected network, and all of those things. And then the fundamental parts, backpropagation, optimization, generalization, those things will be there at the beginning of the course. Okay. So that is pretty much what the course will cover. Okay. Any question about this part? No. Okay. So then let me start or move to the second part of today's lecture, which is, let me try and explain, probably I don't need to explain because you are in this course, but let me still try and explain why deep learning is relevant in general, but also why deep learning is relevant in mechanics. As I said, there will be some mechanics motivations that I will talk about today, mechanics problems that you can solve with deep learning and data-driven methods in general. So let's go to that part, right? Now, all of you are engineering students, right? And as an engineer, I always say, or I always believe, that your goal is to model, analyze, and design complex systems or systems in general. And that is how what distinguishes an engineer from a scientist. A scientist or science or the role of scientist is to make sense of the world around us. Science is about explaining the phenomena that is happening around us. If the apple is falling from the tree to the ground, why is it falling? That is a phenomena that happens. Science explains that. And in the process of explaining it comes up with its own theory, hypothesis, uh, equations, laws, uh, axioms, and all of those things. So science is about making sense of the world around us. Engineering, on the other hand, is also known as applied science in many places. So engineering is about changing the world around us. So engineers build bridges. Those are not natural things. We are in a building, not a natural thing. So engineers uses the scientific discovery carried out by scientists to change the world around us, hopefully for a betterment. I mean, for going ahead, right? And that is why, because it is using science, applying science, you call engineering also as applied science. So, and because it is about changing the world around us, how do you change it? You will model systems, you will analyze system, you will design system. So modeling, analysis, and design of complex system is the goal, more or less. Now, if you follow that, then if modeling, analysis, and design is the goal, and if you look into the world around us, this problem of modeling, analysis, and design comes in different flavors. And what I have shown here on the slide is kind of the two extremes. On one end, on the left, what I have shown you is an autonomous car moving around in a city, a driverless car, right? And for such a system, you have sensors, you have GPS, you have satellites, you have cameras, and you can collect a lot of data, right? But you do not really know much about the physics of driving. I mean, what is physics of driving? I don't know. It's a multimodal kind of behavior, but there is no, I mean, you don't know much about the physics of the problem, right? So that is one end of the spectrum. At the other end of the spectrum, which is a more mechanical kind of thing, it is about a wind turbine, right? Flow around a wind turbine. And for such a system, collecting data is difficult. You will not have enough data, because if you have to run simulation, that will take months, single simulation. If you have to collect data using sensors, you will get very sparse data. How many sensors will you put? So you will get data either sparse in time or in space. And that is why I said these are the two extremes. One extreme, you have enough data, but you don't know the physics. The other extreme, you don't have enough data, but you know the physics. The physics has been established, so we have something to build on. So on the left, that is what basically classical machine learning and deep learning works with. Data. So from the data, how can you use it to model, analyze, and design systems? On right, this is where computational science, not computer science, computational science and engineering works on. CSE. That you know this physics, can you develop algorithms to use that physics to simulate? So developing simulation engineers will use that. And any real problem that you can think of will reside in this one-dimensional spectrum of data and physics. In reality, the problems that we'll use or you will solve, the physics will be known to you to a certain degree, but those will be based on assumption and approximations. Data will be available to you, but those will be sparse, noisy, multimodal kind of data. And you have to somehow make use of both of these to analyze and design these systems. In this course, we will be focusing only on the left-hand side of the spectrum. We will only be talking about data-driven methods. The right-hand side of the spectrum, some of you have learned in finite element CFD courses, and also the scientific machine learning course that I talked about, that is more about the intersection. The scientific machine learning course, whenever I teach it, hopefully sooner, that will be about this intersection where how can you use both physics and data. So deep learning, left, finite element, CFD, numerical methods, I think APL what, now 109, previously MTL 107, that is on the right. And then scientific machine learning, this kind of thing is at the middle, or it fuses the two. This course is about the left hand one. So it is about data and how you can learn from data, and that data can be mechanics data, that's fine. This I already talked about. Challenges is sparse data. I talked about noise, outliers, multimodality. Interpretability is a big issue. We will not cover it in this course, but that's a very important topic, that how can you make sense of the models that you have? Can you interpret the model, make them interpretable? Generalization, we'll talk about it in this course. Can it generalize to out of distribution? Robust design and control will not talk about in this course. That is, there is a course on robust design and reliability based design of which is reliability. And for control, there is a course running this semester in applied mechanics. There is also a reinforcement learning for control, data driven control. So that is also there. So fundamentally, we'll be talking about or handling generalization, noise, sparse data. These three aspects will be covered in this course fundamentally. Just to give you a glimpse, what are the different problems that you can solve with deep learning in the mechanics domain? Why is it? Why? I mean, why there exists a course called deep learning for mechanics? Certainly, there should be problems in mechanics that deep learning can help solving. So there are some problems like that. For example, and most of these are actually work I did or my group did at some point of time. So the first one, I mean, probably you have not done a course on fracture mechanics, most of you hopefully, but fracture mechanics is a very important problem because this is about studying failure of systems, right? And through crack propagation. Now, a fracture mechanics simulation is something which takes huge amount of time using finite element method generally, or yeah, SPH also people use, but using numerical methods. And there have been evidence, there have been worked where people have worked on developing AI algorithms, and they have showed that with AI algorithms, you can probably accelerate it manifold. So you can solve it much faster. And solving it much faster means you can also scale it to larger structure. If you basically, if you keep the problem same, time will reduce. If you keep the time same, the scale of problem you can solve will increase. Okay. So that is a crack propagation in material. Modeling of joints is another important problem. In fact, most failure starts happening from joints, beam column joints, and all of those things, right? So actually failure starts from here because that is your weak point, because you construct them separately and then weld it, bolt it, or something like that. And joint analysis is another, contact analysis, for example, is another very difficult problem to solve because of the two modeling the contact behavior is very difficult. And AI has a role to play there as well. AI can help you solve this contact mechanics problem in an accelerated manner. If something is unknown, constitutive relation, let's say, you can always collect data from experiments and model it using AI. So constitutive relation, right, which is the stress strain relation in general. Constitutive relation is always data driven, by the way. I mean, C, even if it is linear elastic, C is equal to sigma times, sorry, sigma is equal to C times epsilon. That C you find out from data and by some model fitting. And that is with the linear assumption. If it is non-linear, that is all, I mean, data driven. Okay. I mean, there is some energy function and all of those things, but then the parameters are data driven. So constitutive relation, for example, is always based on experimental data. Yes, it was not done by machine learning earlier. People were looking at the data, analyzing them, those, and coming up with their own models, but it is data driven and it has assumptions. And that is why your physics is based on assumptions and approximations. Okay. Third, multiscale. I think you have a course this semester on multiscale. Most of you might have done it already last fifth semester. That's a common trend, but multiscale, you know. So multiscale again is very expensive. So that there also AI has a huge role to play. In fact, there out of these three, probably that is the problem where AI has the most significant role to play, because at the micro scale you use AI to accelerate, and then at the macro scale you use FE. So it will be a AI or ML FE kind of combination synergy. Lastly, vibration control, a typical problem for RL. People use RL to solve this kind of problem. So reinforcement learning has a huge role to play in vibration control of an aircraft, of a building, of a robot, to control the robot, not vibration, but robot control. in general, right? So that is where you use reinforcement learning. And you can probably see that these are all problems from solid mechanics, right? Going to fluid mechanics, the applications are even vast. Climate modeling or weather forecasting model. I mean, right now, weather forecasting is one domain where AI models have outperformed the numerical simulation. The most popular weather models are, for example, ForecastNet by NVIDIA, GraphCastNet by Google, then there is Aurora by Microsoft. So all of these big tech giants have their own weather prediction models based on AI, deep learning in general. So, and Aurora is also a foundation model, so it can predict extreme events and all of those things. So, and this is one domain where AI has kind of overtaken numerical simulation. Fluid structure interaction, a very difficult problem. Multi-scale was there, but multi-time and length scale, I mean, spatial and time scale also. So multi-scale in both space and time. That is also another problem where AI has a role to play. Biomechanics, a very interesting problem in biomechanics. Often you don't know the physics. I mean, your tissue, what is the physics? I mean, you have some way of modeling it, but most of the things are unknown. For example, I was discussing with one of my colleagues and friend in applied mechanics, and I was talking about, we were talking about, can we have something like, I mean, what is the mechanics of aging? Aging is a cell age, right? So there has to be some mechanics there. That is unknown. I mean, that is probably one of the Nobel laureate level problems. Can we discover the aging, the mechanics behind aging with AI? That's, for example, is one area. And then there was a news article, I think 3 years, 4 years ago, where a twin were born, but they were not separate. So a surgery had to be performed to separate them. But it is a very critical surgery because if it goes through some organ, then they will die. So they performed, they created a simulation world with AI and simulation, tried out 1 million or 100,000 scenarios to decide what is the optimal route of performing the simulation surgery, and then carried out the surgery. And then it was a successful surgery. They were fine. At least at that point they were fine. I did not follow after that. But so surgical simulation, digital twin. So in bio also there is a huge role for AI, biomechanics mostly, cardiovascular mechanics. For example, one of the work we did earlier was on tumor detection. Now, but that is using elastography. So that's a mechanics problem. So the idea is as follows. If you have a tumor in one of your organ, the material property, the stiffness of the tumor will be different from the stiffness of the organ, right? Now, if you have an AI model that based on USG, which is a very low frequency vibration, or MRI, that data can solve the inverse problem and predict the stiffness, then by looking at the stiffness map, you can identify whether there is a tumor or not. So that is known as, that process is known as elastography. Elasto because elastic property stiffness. Okay. Now, if you try to do it using FEM and those kind of stuff, it takes significant time because it's an inverse problem. With AI, you can solve it in seconds, fraction of seconds, to be very honest. So that is one example, for example, which we have solved, where these AI models can really help in a biomechanics setting. And lastly, in design setting, obviously there is a huge role. So again, a new course has been developed, which is known as generative design, which is about how generative AI models can help you in design. There is also work on agentic AI for design. So design is probably one of the places where AI has, again, huge role. In fact, one of the goals of AI is that can we use AI to reduce material design life cycle from 20 years, which is currently, a new material design takes 20 years. From 20 years to 2 years or 3 years. Boeing, for example, takes 10 to 20 years for designing new aircraft. I mean, because they have to do experiments, validation, and all of those things. With AI, can you reduce it to, I don't know, 3 years? So these are like open problems where AI has a role to play. Okay. So fundamentally, what I'm trying to say is that in mechanics, in engineering, in mechanical science in general, or bio, AI has a huge role. And that is why there is a course which is deep learning for mechanics. Okay. Although the course is about deep learning for mechanics comes from the fact that this course, the practical components, the data sets will be mechanics data. And also it comes from the fact that this AI, I mean, this model has huge application in AI. Okay. Any question? If not, I will go to the last part of the today's lecture. Okay. So now let me ask some question, right? I've written what is artificial intelligence, forget about artificial part. What is intelligence? If someone asks you, can you define what is intelligence? What is intelligence? Have you thought about it? We all understand that he is intelligence, he is intelligent, he or she or they are not intelligent. Those kind of notions we often use. But what is intelligent if someone asks you? Can you define? You can try, right? I mean, yeah. The ability to for to take informed and accurate decisions, right? Now I can reverse it and say that is that the definition of intelligence or is that a property of an intelligent being? An intelligent being is able to take informed decisions, right? But that is a property of intelligence. But what is intelligence? I'm not saying I know the answer. I also don't know the answer. And I'll show you some definitions from dictionary also, and you will realize that the answers that the dictionary gives is very similar to what we just heard, which is more about what are the properties or features intelligent beings should have. And this is not only about intelligent, I mean, this is about most basic things that we have. For example, what is a table? What is a chair? If I ask defining you what is a chair, it is not so easy to define what is a chair. You will say, for example, I don't know, a table has 4 legs, for example, let's say. A chair also might have 4 legs. A sofa might also have 4 legs. A bed might also have 4 legs. A table is where we can keep stuff. I mean, we keep stuff in other places. Almirah also, bed also, we sometimes keep stuff. So it's not so simple, and it's okay. It's okay. But the obvious things, often the definition is very difficult for the obvious things. Okay. So what is intelligence, I asked? The notion of intelligence, obviously you can understand, started from human being, right? I mean, the concept is that human beings are intelligent. And that you can see even in the scientific name. What is the scientific name? Homo sapiens, right? What does Homo sapiens means? Wise man. So even from the scientific name of human, this I mean, so we have a tendency of linking intelligence with human, right? And that is why often you will see that can you do something, can a machine think like a human? Because if it can, then it is intelligent. Now, I personally feel that is also a very egoistic way of looking into things, that we are saying that we are the intelligent one, there cannot be anyone more intelligent than us. But that's up for debate, but yeah. So yeah, we are I mean, and Homo sapiens, because they thought that we are entities blessed with wisdom. Now I can ask, what is wisdom? The ability to perceive, think, understand and manipulate things, create art form. Someone say that that is a form of intelligent, others cannot create art form. Again, someone can argue, some birds make their nest, which is a very good art, so they are probably creating art form. Formulate language and scripts, that is something we do. Make sophisticated tools. So yeah, so I mean, historically human beings have been linked with intelligent, right? And yeah, so this is, for example, a sculpture, which is the thinker is what they call it. And if you look into dictionary, capacity to acquire and apply knowledge, I mean, similar to what was said, the faculty of thought and reason, one who can think and reason is an intelligent being, right? And because of this confusion, because of this lack of clarity, uh, this lack of clarity in definition of intelligence shifts into lack of clarity in definition of artificial intelligence also. And as a result, if you look into definition of artificial intelligence, there are four schools of thought. The first school is that thinking like human. So human is intelligence. If you can think like human, you are intelligent. Okay. I can always ask, how do you know I am thinking or not? And I mean, I don't know. Is my watch thinking? How do I know? How can anyone know if someone is thinking or not? You can only know someone is thinking or not if there is a response. If you ask a question and he or she or they answers. So thinking like human, I mean, people argued, makes no sense because you will not know whether someone is thinking or not even in the first place. And that's where the second definition, which is here, comes into picture. Where they say thinking, I cannot know whether someone is thinking or not. Let us reduce it, the space, and let's say acting like human. Because if someone acts like human, they must be thinking. So, and if they are thinking like human, they must be intelligent. Right? So, this is the first two things. And then people say, but what I said earlier, does it not mean that we are only saying humans are the only ones who are intelligent? And why are we even comparing with human? The definition of intelligence would be independent of human. Then only we can actually, do something about that. And you will see one thing. And this definition has some issues also. Look at this one. Can you read it? I will read it, but is it visible from the end? So what is it saying? The study of how to make computers do things at which, at the moment, people are better. Do you see any problem with this definition? And it is 1991 when this was given. The problem is at the moment. So right now, the computer is bad at, say, I don't know, what is the computer is bad at? Many things, right? So one of the things, let's say, is computer is bad at, let's say, doing maths than human. Okay? So if I can make the computer do maths better than human, I'll say the computer has become intelligent. But tomorrow, the computer is now better at doing maths than human. So tomorrow it is not intelligent. So the definition, the goalpost is changing when you are comparing like that. When you add at the moment, so what is intelligent today, because human could do, machine could not do, tomorrow that will not be intelligent. Tomorrow means 10 years down the line. Because at that point, this was already a fact. And a good example is chess. So chess has always been a very good use case for AI. And people have always tried, can we beat the champion, right? And that first time that happened in 1996, where Deep Blue defeated Garry Kasparov. So that means that was the inflection point, and AI, the machine became intelligent. But now, if any champion plays a, let's say, AlphaZero, the champion will lose. So, but that is not intelligent, because at this moment computers are anyways better at playing chess than human. So these are things that people pointed out. Okay, and that is why the second class, the blue one you were seeing, which is like, it's not about human, it's about ideal performance. And so it comes, and again the two things come: thinking rationally, and then the most accepted one is acting rationally. Thinking rationally is not that accepted, because how do you know someone thinks? The same issue, right? Acting rationally is more, because if someone is acting, then you know, right? Yeah. So these are the four kind of definition: thinking like human, acting like human, thinking rationally, acting rationally. What does acting rationally means? There is a goal, and whether the machine is able to achieve that goal. If it is able to achieve that goal, it is acting rationally, because it is acting towards a goal, and so it is intelligent. Okay. Obviously, I would have talked much more. I've taken maybe 2, 3 lectures on this thing, but I would have done that if it was a course on AI and not deep learning. It's a course on deep learning, so I'll keep the discussion on AI limited to 2 slides. Okay, if you're interested, you can take a course on AI. You will see that history of AI and all of those things are covered there, which is very interesting, by the way, but not for this course. Okay. Any question? These are just discussion right now, anyways. What I said, AI versus ML versus deep learning. What is the difference? AI, ML, and deep learning. Any the difference you are? Can you tell? We always use them interchangeably nowadays, but they are not same. So can you articulate what is the difference between AI versus ML versus DL? AI is also for problem solving, I can say, because rationale, right? So that is about, so in that sense. But you are in the right direction. Maybe think a little bit more. You might be able to reach there. So AI is a broader framework. It is about problem solving. Machine learning is a way of solving problem through learning. That's why the term learning is there. So machine learning is one way of achieving AI. It is not the way of achieving AI. There are other expert systems and all of those things which are also AI, but they are not learning based systems. So if it is not learning based system, that is not machine learning, but that can still be AI. For example, there is something known as A star algorithm, which is a search algorithm. Now, search algorithm is not a learning based thing, but A star algorithm is an AI model. So AI can be with or without learning. Because if you look into this definition, neither of this is talking about learning. It is only talking about thinking and acting. And it is talking about thinking humanly, thinking rationally, acting humanly, acting rationally. Right? So AI is about one of these four, whatever you subscribe to, right? On the other hand, learning is one way of achieving AI, and that is machine learning. Deep learning is a subset of machine learning where we use what is the so-called deeper models, and we'll discuss what deep means in the context of learning later, not today. So we use some subset of machine learning algorithms are known as deep learning algorithms. So there is this concept of deep neural networks. So they are part of deep learning. There is this concept of deep Gaussian process, which will not cover. That is part of deep learning algorithms. So when you use these deeper models, um, they become the deep learning part, and that is what we will be covering. Machine learning is a broader set, is a superset, and deep learning is a subset. AI is encompasses both of these, and that is what this diagram was showing. So you can see AI here, right? And there are exam knowledge based systems. Then I said search A star algorithm. Then there is machine learning here, and within machine learning there is representation learning, which is a shallow learning, and then you have the deep learning. So you can see deep learning is a subset of machine learning, which is a subset of AI. I always say AI is like a goal. Okay. And for achieving that goal, there are different algorithms. Machine learning happens to be one broader set, or most popular at least today. So clearly you can understand in this course we will restrict ourselves to this inner circle only. We will not talk about anything in the external part, at least for most of this course. Okay. Any question? Attendance. Okay. Now machine learning versus classical programming. What is the difference? It's a very simple kind of thing. In classical programming, you give your input and you also give your rules, and what you get is the answer. In machine learning, you give your input and you give your answer. Supervised learning I'm talking about, although I've not defined what is super learning. So you give input, you give answers, and what you learn is the rule. So that you can now use that rule to generalize to new inputs. So classical programming, you have if, else, for, and all of those rules, right? And you use that to get an answer out of a question. In machine learning, you have data, and it is somehow learning that rules, which might not be interpretable to you, which might be in an abstract space, but that's what it is trying to learn. And then use that rules to make uh, predictions. Okay. Okay, so I will spend another 10 minutes maybe. So I have another 10 slides, but I'll take not go to those slides mostly. That I'll do in the next lecture, most of it. But so how many of you have machine learning background previously? I mean, some machine learning course you have done earlier. I mean, obviously you have done generative model, most, right? Is there anyone who has not done any machine learning course earlier? You? So I'm guessing you are the MTechs, right? Because they are the only ones. So anyway, so we'll cover very quickly machine learning, but it's fine. Don't worry. Okay. Uh, so anyways, in machine learning, there are three types of broadly specifying three types of problems. One is known as supervised learning. The other is known as unsupervised learning, and the third one is known as reinforcement learning. So what is supervised learning? For those who have done a course, it's very simple. So what is supervised learning? Label data, right? So basically you have XY pairs. For example, in this classroom, if I have to create a supervised learning problem, I can note everyone's height and weight. That is my input, and I can note your gender. Or I can note your region from where you come. And now given this height and weight, can I predict whether you are male or female or from which region of India you come? So that becomes a supervised learning problem. So in supervised learning problem, there is the sense of data and labeled data. So data is labeled. You have input and output, both are available to you. Okay. So that is known as supervised learning. That means I have my height and weight, but I also have for each height and weight, what is the gender I am observing. For each height and weight, what is the region or state I am observing, something like that. And that's a supervised learning problem. Okay. What is unsupervised learning problem? Unlabeled data. Example. Like I gave the supervised one, give an example for unsupervised. Yeah, so basically, I mean that it might not be able to do, but cluster them is what you are saying, right? So basically, I'm giving only height and weights. The gender part is now missing, and now based on this height and weight, how many clusters can you form, right? And maybe each cluster represents some state, but you will not know that. Maybe there will be only two clusters, male and female, but you will not know which one is male, which one is female, without your expert knowledge. It will just tell you that there are two groups that are emerging in this data. So this is known as clustering. Clustering is one example of unsupervised learning. There is other examples also. I give you a lot of data, right? Height and weight, let's say. Now, can you generate new data for height and weight, which might not be here, but that is a possibility if before add and drop more people register. So there's an add and drop period, right? Right now I have what, 30 students maybe sitting here. Okay. So I have this 30 data. Based on that, can I generate new data, which is possibly the height and weight of students who might register for this course in the next 10 days. So this is known as distribution learning. You learn what distribution the data is from and then sample the distribution so that you can generate new data. This is the whole idea of generative modeling, which we will not cover mostly, but this is what was covered in the last time I taught generative model, which is now last semester. So in generative model, this is what you do. You learn the distribution of the data and you learn how to sample from it. Chat GPT and all of these things are generative models in general. Okay. I'm not saying they are unsupervised generative model, but they are generative models. Okay. So two examples I give, unsupervised, one is clustering, one is distribution learning. There can be a third one, which is to find some latent space. So I have a data, can I find some latent representation of that, which might not make sense, but it is a latent representation. Now clustering is one way of thinking it is a latent representation because male and female is what I talked about. But in this case, it was making sense. For example, if I give you images of human faces, maybe the latent representation is what? How does my face differs from his face? Only the face, not the height, right? It will what? How my eyes look, how my eyebrows look, how my nose looks, how my ear, lips, maybe beard, and all of those things, right? Shape. So these are like latent variables. Although my image might have, I don't know, thousands of pixels, right? Image is based on pixels, so it might be a very high definition or HD image, but practically that high definition, high number of points means nothing. It only means that how many points are there. I mean, how many things actually matter. So this is known as low dimensional representation learning. So remember here I was showing representation learning. So that is what it is. Okay. And the third one is reinforcement learning. Again, what is reinforcement learning? This one probably you have not learned. So, but tell. Right. So reinforcement learning in one word is learning from experience. For example, let's say I'm teaching this course for third time. Actually, I'm teaching this course for third time. Anyways, okay. Now, when I've taught it first time, I might have taught in a different manner. Based on the student feedback, I learned that no, this is the thing students are learning. This is the or they are liking, and these are the things students are not liking. Now, and based on that, I probably changed my way of teaching the next time I taught the course. And then I got some feedback, and maybe this time I'm doing something else. So this continuous process of evolution, this continuous process of updating myself is the idea of reinforcement learning, where the agent, which in this case is me, take an action, which is teaching, in an environment, which is this classroom, and then from the environment I will get some reward, which is feedback, let's say, or one-to-one interaction. Feedback might not tell everything, but one-to-one interaction also, right? Or looking at your faces when I'm telling something, I mean, that also is a reward. And based on the reward, I will update what action to take next time, which is how to teach next time. So environment is where I am, classroom. Agent is the one taking action, which is me. Action is teaching in this case. Reward is whether you are learning or not, whether you are happy or not. Again, happy in terms of learning. You might be unhappy because I'm giving more assignments, so that I can ignore also, right? But yeah, happy in terms of learning. And based on that, updating my action. So this is reinforcement learning. We will have 3 dedicated lecture on deep reinforcement learning. That time we will go into the more mathematical aspects of this. We will have lots of lecture on supervised learning. That is when it will become more concrete. Right now I only want to understand it in a broader sense, right? And unsupervised learning, we'll have some lectures, not much, but we'll have some lectures on that as well. Okay, so supervised learning, unsupervised learning, reinforcement learning. These are the 3 paradigms, broadly speaking, in machine learning. Okay, and we'll talk about each of this slightly in the next lecture, but then we'll talk much more about this in the throughout the course, basically. Okay, but supervised learning, unsupervised learning, reinforcement learning. The other way I think of it is that supervised learning, you can think of like a teacher teaching in the class. So you are learning from a teacher, that's supervision. Unsupervised is like you are learning from by going to a library and reading books. So learning on your own, unsupervised. And reinforcement, anyways, all human being learns from experience. So reinforcement learning is anyways very natural to human beings. Okay. So I will stop here actually. And then we will meet next on Monday, when the actual course will start. Today I just wanted to give you or talk about the course modalities and give you a broad introduction to um, deep learning in mechanics, AI ML in general, so that to set the stage basically, right? Any questions you have, you can ask now. Uh, I think 2 signatures are remaining. Till then, if there is any question, you can ask. Otherwise, we will close now. Okay. Is there any question?
Sir, why are Google and Microsoft building climate models?
Building
Climate models.
climate models. Why should they not build climate models? Let's put it that way. Why does any company does anything? I think that is the actual question. For profit, right?
But sir, how will Microsoft benefit from a climate risk?
Because they can predict when something will happen. So let's say that there is a disaster management team, right? If Microsoft can build accurately when a disaster is going to happen, that will help the disaster management team, right? So they will use these models.
That changes their domain where they actually.
You are in a time when there is nothing called domain. There is a program that many of the students here are registered in, which is known as engineering in computational mechanics. I think this is the most interdisciplinary program that exists in IIT Delhi today. They learn about AI ML, they learn about mechanics. Why did you sign? By the way, only those who are registered should sign, not the ones who are sitting through. You should not sign from next time. Okay, just letting you know. I know. So I'm just announcing. So it is for attendance. So I'll not penalize someone who's sitting through for you did not attend the course. That will not happen, right? So only those registered audit or credit should sign. So yeah, to continue your part, right? So the point is that the world is interdisciplinary. In fact, the world was already Do you know how these engineering branches emerged? Do you think the engineering branches were there at the beginning itself? What is the oldest engineering branch? Civil came little bit later. There is one before that, military engineering. So military engineering and then military and civil engineering. That's how it was.
Military contained everything.
Obviously. And then from there, things started getting divided because specialized problem emerged. So the engineering disciplines were created because the problems were specialized, not because they are separate. And now we are going back because the problems now are multidisciplinary. And because the problems are multidisciplinary, so now they are getting multidisciplinary. People are interdisciplinary. So people are coming together, working together. Microsoft is also working on material, by the way, to develop new material. Microsoft is also working on obviously their usual computer stuff. And all of this is going to help them and profit them. NVIDIA, for example. NVIDIA is building climate model. Why is NVIDIA building climate model? NVIDIA is investing hugely in these algorithms and giving it for free. Why do you think NVIDIA is giving it for free? Because if they give it for free, to use those models, you have to buy NVIDIA chips. That is how they will profit. Microsoft is building data centers. To use those weather models, you have to use those data centers. So they will want people to use those weather models, which they will give for free. And then for data center, where will they go? There is Amazon Web Service, Microsoft and Azure and all of those things, right? So you first create the need so that they are forced to buy your product. And that's how business works. That's how business should work. Business is about profit making, right? So that's the idea. Okay. Any other question? Okay. Okay. Thank you.